let me go back here. All right. So, any other questions, comments, thoughts? How are you doing? Check in.
Good. Yeah, I received 1 or 2 messages.
Excellent.
From last week when you said the mentor email thing.
Okay.
So, yeah, it's nice to speak to a couple of other people. Just to see how they're doing.
Fantastic. If you need help, literally, and this goes to everybody, if you need help, especially if you're in the first semester, reach out to the third semester students. We sent you a bunch of contacts. They happily are donating their time to talk to you, connect with them, and they can explain exactly what happens in the program. They can tell you important things that you have to know and help you along the pathway. It's good to have somebody to talk to and make those connections. Now that you have Ray's LinkedIn, you could easily connect with him too. But I'm saying, it's a good idea. JP is also very happy. Okay, so since we're here and you're paying me to talk for 15 more minutes, I'm going to show you something totally different that's not related to anything. Are you ready?
It's not the sea shanty, is it?
Oh, new thing you haven't seen yet. Yeah. You think I only know one trick? I know many tricks. Don't worry about it. Yeah. All right, so we're going to do some very, very fast machine learning. This uses the website Machine Learning for Kids. And basically what we're going to do is a feature detection algorithm. It's really simple. You can export everything I'm going to show you today in Python. And after the class, I'm going to email out everybody the links to everything that we covered today, including this. The idea is you could build some really simple models for recognizing text, recognizing numbers, recognizing handwriting, recognizing images from your webcam, or many other things, and you can run it in Python. Right, so I'll show you how to generate all of that and get started with machine learning. If you're in first semester or even maybe second semester, this might be too complicated. But since the front end is super simple, it's easy to do. In fact, you could even export the results in Scratch. So it makes it really simple to do, right? We're going to work on a project. We're going to recognize some images, 2 different kinds of images. What kind of images would you like to compare to each other?
Face and maybe your was it your 300 eggs or something like that? Or?
Okay, so Ray has a problem. All of you know Ray. Ray is unsure about what is a chicken and what is a monster truck. So we're going to build a database of what is a chicken, what is a monster truck. Every machine learning project has 3 different steps to it. Step number 1 is build a database of chickens and trucks. Step number 2 is try to recognize features, but it's automated. This is called unsupervised learning. The computer figures out, based on all the parameters that are in every picture, what can we recognize from each one? And it does not tell us. So the model that goes in behind it could be made up by many different factors, right? Does that make sense? So for example, if I look at JP, how do I know that JP is not the same as Ray? There could be many reasons why, but my brain just tells me they're different, right? The computer is very complicated. So when we feed it in many, many different pictures of JP and many, many different pictures of Ray, it becomes harder and harder to trick the computer that one is the other or a third totally unrelated person is one of them. Make sense? In this case, we're using categorical data. We're trying to train the computer, what does a chicken look like? What does a monster truck look like? And then find out which one is which. So let's get started. The first thing we're going to do is we're going to go to this website called Machine Learning for Kids. I'm going to start a new project, and the project name is going to be called Monster Trucks and Chicken, and we're going to recognize images. Yes. What do you say?
Sorry, sir. I would appreciate if you can record this as well, so we can have a copy of it.
Yeah, but let's say I make a mistake. I'm volunteering my time here. Don't put me on the spot. All right, I'm going to send you the links. You can figure it out on your own. Don't worry about it. Okay. All right. Every machine learning project has 3 phases. Phase number 1, train the model. Phase number 2, learn what the model is. Figure out what's inside of there. Again, this is hidden, but it makes the computer check the model. And then finally, we could put it into Python or somewhere else. So let's start at the very beginning. We're going to go train. And to make this work, we need labels or buckets of our 2 different categories. Our first label is going to be called chicken. Our second category is going to be called trucks. Okay. Now, we could do a third category. Ray also likes cookies. Make sense? Okay, now to make this work, I'm going to go and open a Google Images. I'm just going to put it off on the side there. And we have to have about 15 of each kind of picture to train it what a chicken looks like. Now, it's very important. This is critical that when we grab a picture of something, it's showing me a lot of pictures of cooked chickens. I think we need chicken that's alive. So when we train the data, we do not want to use our training data overlapping with our testing data. And this is extremely important. The reason why is because we're not asking the computer, remember 100 pictures and then tell me if this one is inside of that group. Instead, we're saying, here's 100 pictures of a chicken. Does this new picture look like a chicken or does it look like a cookie? Does that make sense? Okay. So it's really important that we cannot use pictures that we've already used. For example, I make 1 million pictures of Ray, so we know what Ray looks like. I may make 1 million pictures of JP. I know what JP looks like. And then I take a picture of Jason and I say, is Jason, JP, or Ray? If I put Jason's picture into Ray's folder, the computer would know that Jason looks like JP, like looks like Ray, because I'd already trained it like that. Sorry if that's complicated, but basically, let's drop in some pictures and we're going to do about 15 pictures for each one. So I'm just going to drop in a bunch of different pictures of chickens. Right, and we're doing all kinds of different chickens. And if you think about how does a computer recognize a chicken, chickens have a certain kind of face. Chickens have certain colors. Chickens have feathers. They have certain features. A computer doesn't recognize what a chicken is like we do, but it has a pretty good idea of how we could do a composite of all these pictures in order to figure out what a chicken looks like. So far, so good? All right, so we have some chickens. Next, let's do trucks. And we're going to do monster trucks. And we'll add in some pictures of monster trucks. All right, monster trucks are like these gigantic trucks that have huge wheels on them. And they clearly do not look like chickens. So we'll put in about 15 of those as well. So the computer can kind of figure out what does a monster truck look like. They do have different colors. They don't all look the same. They don't have the same orientation, but they do share certain features, like they have giant tires, right? And they definitely do not look like chickens. You could disagree with me, but. All right, so we have a bunch of pictures. All right. And lastly, let's grab some pictures of cookies. And we'll throw some of those in here as well. And again, what do cookies look like? They have a certain texture, they have certain coloring. They might have, certain ingredients or positioning. And really, it's kind of, we're training the computer to pick up on these differences, even though they might have different colors, they might have slightly different shapes, they might look slightly different, but we're trying to look at, based on all the factors, what are the commonalities between the various images. All right, so let me grab a few more, and then I think we're good. All right, so we're done. We have our 3 sets. I'm gonna go back to the project. Now we're gonna go learn and test. This will take a minute because we collected 20 examples of chicken, 18 examples of trucks, 22 examples of cookies, and we're gonna train our new model. Right, so it's gonna try to figure out which ones are those various elements, and they'll make them work. Right, we'll just take a second to put it together. It's gonna train them, and there we go. So now we have this new model that's behind the scenes. It has the parameters of what they look like. And we're gonna grab a brand new image of a chicken. Let me grab one that I have not looked at before. And here's the new picture of a chicken. And I'm going to, hold on, open this up. Okay, if you're interested in taking a look at this chicken, here it is. Feast your eyes upon my chicken. I'm going to copy that into this link, and we're going to press test. It says it recognizes it as a chicken 100%. Okay. How about if I draw a chicken? I'm really bad at drawing. So here's a chicken. Here's the head. It has like a little thing that sticks up here. I think I just made like a punk rock chicken. All right, so it has a body, and it has some kind of like wing there, maybe an eyeball, and it has some feet. Okay, press test, and it's 85% sure that that's a chicken instead of a monster truck. So what this means is that if we feed in a cookie, a monster truck, or a chicken, it will recognize what exactly that image is, right? So we can build some really, really powerful programs that will be able to detect between these three things and recognize what they are and use that logic inside of many other programs. So we could test it with the webcam. Should be interesting. Oh, I'm already using the webcam. Let's try this again. So 85% confident that's a cookie. Why? It's round, it has a smiley face on it, etc. Okay, now if we go back to the project and we press make, we could export the code that we used into Python, and we could put in this image file, and it brings back your script with the results, whatever. This is the API key that the system gives us. And basically, it will import machine learning for kids code and then make this work. Let's take a look if this can work in Replit. I'm not sure that it can, but it might. Let's give it a go. So we'll go open up Replit, and we'll go into Python. We're going to paste this in, and we'll press run. And it says it can't find this package. The reason why I can't find the package is because Python in Replit will automatically install packages that use PyPy. And if your package is not in PyPy, it won't work. But we can install it manually inside the shell. We're just going to add -- user. Look at this. Oh, we have to download this file. Okay, so hold on. Save link as. Okay, give me a second. And we'll drop this into the same folder. There we go. It's running. It's installing TensorFlow. TensorFlow does not get along well with Replit just because it's such a huge package and it takes up so much memory. But TensorFlow will help us connect all the different pieces together, I hope. Thinking, running, processing. So this key gives us access to our model, the one that we created with all those pictures. Then it takes our model and we're able to change it. Now this picture, right, mytestimage.jpg, we can grab a picture and put it into here. So I erased the picture of Ray, but let me grab a new one here. Hold on. So here's a picture of Ray. I'll put it into here, and I'm going to call it ray.png, and I'll rename this ray.png. Okay, so then we're going to come back with this label, class, and confidence. Again, installing TensorFlow on Replit is not a good idea because it takes a really, really long time. But when this is done, it will tell us how much Ray looks like a monster truck, a chicken, or a cookie, and in what percentages it was able to match the model of what we built before, right? So this just takes a minute because there's so many different things to install when you're putting in TensorFlow, but we'll see if it works. It doesn't always work really fantastic, but we'll give it a second. Anyway, any questions? Do you understand what happened?
Yeah, this is super cool. The website gives an API exposure.
It gives an API key, an API key to that model. And every time you build a new model, it gives you a new key. So that model would only work for monster trucks, chicken, and cookies. Whereas if we built a model that recognizes handwriting, that recognizes, cars, that recognizes colors, we would have many different buckets that do different things. It just depends on what we're trying to accomplish. Right? So we're still installing stuff. We'll just take a second. and then we'll give it a go. It's installing a million different packages. Right, all the data that's downloading now is the data that we previously uploaded, all the pictures.
Mm.
Okay, so we'll give it a second. It says starting to train the machine learning model. In a second, it's going to crash because we didn't provide it with Ray's picture yet. I have to run it again. Right. Okay, let's just stop this for a second and we'll give it another run. Everything should be installed. All right, so we found 43 images belonging to 3 classes, defining layers to include your neural network, starting to train your machine learning model. So this is doing the training from the beginning. And then we're recognizing this image. So that will take a second because it will have to go through, and it's looking now at 43 different images in each of the 3 buckets and figuring out which classes or containers they belong to, and then coming up with the answer, right? So it rebuilds the model every time. We could skip this part if we already have a pre-built model. And then we have the stuff at the bottom. Training complete. Ray's picture here matches trucks with 50% confidence. I'll leave that for you to ponder because I don't know why it thinks Ray looks like a truck. I will not comment on that. But I hope that you have a fantastic weekend. Don't do too much homework. Go outside for a walk. End of week 3. Next week, we'll work on some new stuff. And I'm going to send you a list of everything that we did today, including all the links for HTML, for templates, for building the template, as well as the machine learning examples that we looked at. Machine learning is really complicated, but getting starting with this is really simple because it gives you the Python model and you can get it going in 2 seconds and then find out if Ray indeed does look like a truck. You can maybe ask Ray for more pictures so you can make sure that's true, but I'll leave that up to you. All right, I'll see you later. Galkushe, what do you say?
Yeah, it was very complicated for me. I'm not from technical background, but I'm sure that in future I would be able to learn all this.
Galkushe,
Actually,
what's your bachelor's in?
In commerce.
My bachelor's is in political science.
I was totally in hardcore finance. I played with.
So you're more technical than I am. You could figure anything out. Trust me, it's all possible.
Thank you for showing that much confidence on me. I just want to say, could you please show something in next session, something finance with business analytics and what we can do in finance and numbers?
Finance and numbers. Okay. Well, in your class in Python, you're going to go through a whole bunch of examples that use financial data to do very complicated analysis using tabular data and building a bunch of examples. The purpose of the Friday class is not to recreate what you're doing in your other classes. It's to do new stuff you haven't seen before. Yes. So we don't cover HTML in any course. We don't cover machine learning in any course. But now that you see how to do it, you could also start building projects with it. In this course, we have a whole bunch of things that we're going to do. We're going to talk about Flask. We're going to build apps using Flask on the web. So you're able to take Python and bring it out to the web. We have guest speakers and we have a lot of other stuff that's coming up. But finance is not one of the projects that we're doing, but I'll think about it. Maybe we could find something.
Sure. Thank you. And second question. And are we sure that the next semester as well would be online or there will be offline sessions?
We have no idea.
No idea yet. Okay.
It depends both on the college and the health situation as well as on the policies of the IRCC. And they have not yet told us what's going to happen.
Okay. Thank you. Thank you so much.
You know as much as I do.
Thank you.
No problem. All right. Good to see everybody. Have a fantastic weekend.
Thank you.
A portfolio website, fork the code, make your own portfolio website, put it up, and then every week update it. Keep on adding examples that you do, keep on adding pieces, and that's what's going to help you not only build a portfolio for the future, but it's going to show your development as you go through the course. I think from the beginning of the course until the end of the course, especially in programming, but in all your other classes too, you're going to be amazed at how much stuff you produced and how far you got. Ask Ray. Ray started off with 0 coding, and now he's an expert coder. JP started off as an expert coder, and now he's so good there's not even a word for it. So I highly recommend look at the different technologies, save the stuff for your portfolio, use that to advertise yourself. It's a really great idea. And if you have any questions, send me an email. Have a great weekend. Goodbye.
Thank you.
Thank you very
Bye.
much.
Bye.